exponential functions and graphs. You're going to graph exponential functions using transformation properties of graphs. Plus, we're going to get into compound interest. Okay, so for this one here, exponential functions, f of x equals a to the x for a greater than 0, a not equal to 1, and all real numbers x. Negative one will do something a little bit different. I'm actually going to play with this one by putting in negative values so that you can see what's going to happen. When a is greater than 1, but I'm going to put in some values less than 1, but we're going to start with greater than 1. So if I was to say x equals 0, I know it says greater than 1, but you got to know what's going on at 0 as well. Then we have 2 to the 0 power, but we all know that anything to the 0 power is 1. If I put in 1, then we have 2 to the first power, which is just 2. If I put in 2, I'm going to get 2 squared, which is 4, and so on and so forth. So what if I threw negative values in there? What if I put in negative 1? Now I have 2 to the negative 1. Now remember, 2 to the 0 is 1, so it's got to be smaller than 1. 2 to the negative 1, remember your exponents, that if you have a negative exponent, it just tells you the 2 is in the wrong place. It belongs in the denominator, not in the numerator. So this is just 1 over 2. Negative 2, so now it's 2 to the negative 2, gives me 1/4. Notice it stays positive. So if I plot these points, 0, 1, 1, 2, 2, 4, and you can see what's going on over here because I can do 2, 8 next, or 3, 8 next. But at negative 1, it's 1/2, and then it's getting closer and closer to the x-axis. But guess what? This guy here is a horizontal asymptote. He will not cross this because these negative exponents don't affect the fact that the 2 is positive, so it'll stay above the x-axis. And we just connect the dots, and our graph goes off this direction. Okay, it should go a bit further up, straight up, but there we go. Okay, what if my 2 is negative? Well, 0, so now I have negative 2 to the 0 power. Notice the 2 is not in parentheses, so this is now negative 1. Or we can go back to our earlier chapter that a negative on the outside affects your y values, not your x values. And so I put in 0 to the 0 power is 1, but it's going to be negative 1. 1, so negative 2 to the first power is negative 2 squared. Negative 2 squared. It's not in parentheses, so it is just, it's going to stay negative, negative 4. And guess what happens with my negatives? Negative 2 to the negative 1 power is going to be negative 1 over 2. You can count that as negative 1 times this. Negative 2 is now negative 2 to the negative 2 power, so 2 squared is 4. So it gives me negative 1 over 4. Same values as before, but it's flipped over the x-axis. So 0, negative 1, 1, negative 2, 2, negative 4, and going this way, there's our half and so forth. Again, horizontal asymptote. And our graph continues that way. And just like before, if you have a plus c on the outside, not grouped with the x is an exponent, this is going to move it. If it's plus, it's going to move it up. If it's minus c, it's going to move it down. So 0 to the 0 plus 2 gives me 1 plus 2, or 3. 1 is 2 to the first plus 2, which gives me 2 plus 2, or 4 squared. So 2 squared plus 2 gives me 4 plus 2, or 6. Notice that everything is just moving up 2, because these were the values before, and then we added 2 to it. And the same thing is going to happen to our negative values. Now, here's the one thing to point out. This is your new horizontal asymptote. So let me get my line here. Oh, let's use pink. So plus 2, there's my new horizontal asymptote. That is the line my graph is not allowed to cross. So at 0, I'm at 3. At 2, I'm at 4, and then at 6. And going this way, if I had given you the values, they're going to be getting closer and closer to my dotted line. And there goes my graph. Okay, test, quiz, anything like that I give you, if you cross this horizontal line, I will have no choice but to mark you wrong, because that is an asymptote. You're not allowed to cross it. Okay, now what about if I do group it up here? Now if I group it up here, this is your x minus h. So if I have x minus h, it's going to move it that way. If it's x plus h, it's going to move it that way. I have a plus h, so it's going to move it this way. My no movement up and down, so this is the horizontal asymptote. So if I put in 0, I get 2 to the 0 plus 3, which is 2 cubed, or 8. 1, I get 2, I don't think I want to go that direction. 2 to the 0, I'm sorry, 1 plus 3, which is 2 to the 4th, which is 16. Like I said, I don't think I want to go that way, so let's go negative 1. Negative 1. 2 to the negative 1 plus 3 gives me 2 squared, which is 4. Negative 2. 2 to the negative 2 plus 3 equals 2 to the first, which is 2. And negative 3, 2 to the negative 3 plus 3 gives me 2 to the 0, which is 1. So at negative 3, that is when I get my 1. And notice our graphs are exactly the same from there. Up 1, over 1, up 2, and then this next one will be over 1, up 4. Let's see, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. And then, of course, your fractional values here, you're basically cutting it in half each time. And so there's our graph. Okay, and that's what our graph. So again, same thing we learned earlier. It's coming back to haunt you. Grouped with the x is going to move it left and right. Not grouped with the x is going to move it up and down. Okay, so you're going to need your calculators for this one. So right now, I guess you'll just have to take my word for it for the answers, because if you don't have a calculator, but your calculator, I don't have a calculator in front of me, but it's going to be the ln button, which I think is by the number 7 or the number 5, but you'll have to do a second ln to get your e, and then it'll automatically give you a place for the exponent. And e to the 5th is going to be 148.413. You should be doing 3 or 4 decimal places. Oh, it says 4 decimals, and I only wrote 3 on this one. Oh, well, we'll have to deal with it. Okay, same thing here. Second natural log, give you a place for your exponent. This one's going to give you 0.7117. And then e to the 1st is just e. And this is what I should point out here, the number e, just like pi, has a value assigned to it. So e to the 1st power is just e, so it's going to be the 2.71828. So you can give me the 7183 or 7182. I really am not going to be that concerned with it. I'm not looking to see that you can round. So you guys go on that one. So let's look at the graphs of e to the x. So now it says graph it on the calculator, but what they want you to see is that e to the 0 is still 1. And we know e to the first power is 2.7188. You got the deal. So we've got this graph here, and the fact that our graph is going to look quite similar. It might go a little bit faster up, faster down. Okay, but it's still going to look quite similar to anything else. Okay, and then the next one, e to the negative 2x, still e to the 0, so if x is 0, negative 2 times 0 is still going to be e to the 0, which is 1. So we got a point right there. And then if you did e to the negative 2 times 1, you're going to get e to the negative 2, which we don't have the value right off the top of our heads, which is 1 over e squared. So what I want to point out is that it's going to be a smaller fraction, so it's going to be down here somewhere. And if I did to the first power, e to the negative 2 times negative 1 would be just simply e squared. So, which would make it, you know, if we got 2.7, blah, 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 it's going to go up very, very quickly to like 5. So let's just do approximation. 1, 2, 3, 4, 5. So you can see that your graph is going to go up very, very, okay, that's just a really bad graph. Very quickly, it's going to go up. I wonder if I can trim some of that really bad curve off. Just trying to make it look a little bit better. Of course, my hand had to slide right there. All right, good enough. All right. So there you go. So have you go ahead and begin your assignment. The assignment is going to be 1 through 41. Every other odd is like 10 problems or something like that. I don't remember. And they're not all graphing, so you know, don't worry. All right, there you guys go. Good luck.